Hey, ladies and gents, this is Calculus 5.1b. Alright, let's start with our bell ringer. We're going to rewrite ln, the square root of x plus 1, x minus 5, over x minus 1, and times the square root of x plus 3 on the bottom here. So we're just going to take this in parts. I'm going to rewrite this as ln, x plus 1 times x minus 5, and x minus 1 times x plus 3 to the half. Right, so what we're going to do is, right now, I'm going to put this half out in front. So it'll look like this. I'll have half. And then I'm going to have ln of x plus 1, x minus 5, minus ln. Now I'm going to subtract the bottom. It should be x minus 1, x plus 3 to the half. Now remember, this half gets applied to everything in here. So that's why I need that giant set of parentheses. Okay, to make my jump here, I'm going to rewrite multiplication as addition. So I'm going to have ln of x plus 1 plus ln of x minus 5 minus, now be careful here, because I'm going to be subtracting this whole thing. So this will be ln of x minus 1 plus, because it's times, and that half will go in front of my ln, because my exponent will, ln of x plus 3. Close parenthesis for the half. You could distribute the minus in, okay, but that's what we're looking for here. Natural log plus, natural log minus both of these, so that way these both go in the denominator. Half would go up top. Remember, multiplication is addition. That's what they're looking for in your warm-up, okay? So if you're okay with the warm-up, you know where we're going to go next. We're going to go down here to number 1. Right? We're going to go ahead and start with number 1 here, which says find the derivative of the following: y equals x times the natural log of x. This is product rule. So when I do the derivative of y, this will be the derivative of x, which is 1 times the natural log of x, plus x times the derivative of the natural log of x, which is 1 over x, times the derivative of x, which is 1. So if I wanted to just write this nice and neat, this is natural log of x plus 1. Okay, because these x's cancel out. Going to 2, we're going to differentiate the following: natural log of t over t. I'm going to do quotient rule with this. So the quotient rule says do the derivative of the numerator, which would be 1 over t times 1 times t. That's the denominator, minus, rewrite the top, natural log of t times the derivative of the bottom, which is 1, all over t squared. Right? So we're simplifying. T divided by t is 1, so this is 1 minus the natural log of t over t squared. And you can stop there. Right? Just shift things around. Be right back. Okay, in 3, now they're asking us to find the derivative, plug in our x, solve for our new slope, and then we have to solve for the actual b-intercept using the point in the slope that we get from our first derivative. So let's go ahead here. I need the derivative of this. So y prime equals 6x minus 1 over x times 1. So our derivative would be 6x minus 1 over x. I want to know what this is when x is 1. So my slope will be 6 times 1 minus 1 over 1. We're looking at a slope of 6 minus 1, which is 5. We have this point of intersection. Right? So we know that this point falls on this equation. So y equals mx plus b to solve for my intercept for my tangent line, because tangent lines are linear. 3 equals 5 times my x1 plus b. So this is 3 equals 5 plus b. b will equal negative 2. So our equation for our tangent line is 5x minus 2. Okay? Let's go to the back. Okay, we are going to find dy dx. Notice we have 2 variables here, so that's going to make it more interesting. When I take the derivative of x cubed, that's 3x squared dx, because I took the derivative of x with respect to x, minus the derivative of natural log would be 1 over y to the fourth times 4y cubed. Now we took the derivative of y with respect to x, so we do dy dx, plus 2 dy dx, because again I took the derivative of a y. The derivative of 5 is 0 because it's constant. What I'm actually going to do here now is I'm going to rewrite the 3x squared. I don't need to keep rewriting dx because that's 1. So I'm going to move both of these to the right side. So this becomes now, well, first off, y cubed over y to the third. These cancel out, leaving with just y. So I'm going to add 4 over y dy dx to the right. I'm going to subtract this over to the right as well. So I'll go minus 2 dy dx. So this here simplifies to 4, which is just 4 over y. So that's where this came from. Then I added it over. Now I'm going to pull out a GCF of dy dx, which is just 4 over y minus 2. And then I'm going to divide that over. So my dy dx, when it's all said and done, or finished, will be 3x squared on top over 4 minus y minus 2. There you go. All right, so there is your dy dx for number 4. Okay, number 5, finding relative extreme and inflection point. Everyone's favorite, because now we have to do first derivative and second derivative. So let's go ahead and start with the first derivative. So when we take the derivative of natural log, puts everything in the denominator. And the plus 3 goes bye-bye. Well, not yet. Sorry, I got to just rewrite it at this point. Times 2x plus 2. Okay, so my final derivative for my first guy will be 2x plus 2 over x squared plus 2x plus 3. Okay, now the second derivative, which I would do in maroon. Okay, so I take the derivative of the top, which is just 2, and I'm going to multiply that by x squared plus 2x plus 3, minus, rewrite the numerator, 2x plus 2, times the derivative of the bottom, which is 2x plus 2, over x squared plus 2x plus 3 to the second. So my second derivative, okay, I'm going to simplify this as much as I can. It will be 2x squared plus 4x plus 6 minus 4x squared, 2x, that would be 4x, so I'll be subtracting a positive 4x, subtracting a positive 4x, and then subtracting 4. All over x squared plus 2x plus 3 squared. So we're looking at negative 2x squared. These 4x's cancel out, leaving with just minus 4x. And 6 minus 4 is 2. And I still have x squared plus 2x plus 3 squared all on bottom. So there's my second derivative. Here's my first derivative. Now, keep the ball moving. Let's know when this equation will equal 0. So we set 2x plus 2 equal to 0. So 2x equals negative 2. X will equal negative 1. How about when will this be undefined? Okay. So to do undefined here, we set x squared plus 2x plus 3 equal to 0. 3, there are no numbers that multiply to be 3 that add up to 2. So this is a quadratic formula. Let's just see if we get an imaginary number or not. Okay, b squared would be 4. Minus 4 times 1 times 3. 4 times 1 times 3 is 12. And you can see I can pretty much stop at this point, because I'm going to get an imaginary number down here, which means it's not real. So I'm going to get no critical points from this one. So my interval to test here would be from negative infinity to negative 1 to infinity. So I need to pick a point. I'll go negative 2 and 0. I'm going to plug these into my first derivative and see if it gives me a positive or a negative. So if I put negative 2 in, that would be negative 4 plus 2 all over. Positive 4 minus 4 plus 3. So that's negative 2 over 3, so that's going down. Put 0 in. Put 0 in, I'm going to get 2 over 3, which is positive, so I have a minimum at negative 1. Okay? So my relative extrema, I will have a minimum at negative 1. If I plug negative 1 in here, we'll get 1 minus 2 plus 3. All right, which would be negative 1, 2, ln of 2. So whatever natural log of 2 is my y-coordinate. Okay? All right, so there's my min. First part done. Now let's solve for my inflection points. Okay, so inflection points, we have to do the same thing now with the second derivative. So let's find out when this is equal to 0. So I'm going to pull out a negative 2. That's going to become positive x squared plus 2x minus 1 equals 0. Okay, so basically what I did is divided all these by negative 2. So negative 2 divided by negative 2 is positive 1. Positive 2, negative 1. And then I divide 0 by negative 2, that's why it's gone. So there's nothing that's going to factor to be 1. And basically, numbers that multiply to be 1 that have a difference of 2. There's no such thing. So again, I'm doing quadratic formula. This would be negative b plus or minus b squared, which would be 4. Okay, and then I got 1 times 1, which is 1, which is negative 1, times a negative 4, which is plus 4. So this is going to be a real solution. So this is x equals negative 2 plus or minus the square root of 8 all over 2. So we're looking at basically negative 2 plus or minus 2 root 2 over 2. So x is negative 1 plus or minus the square root of 2. So I have 2 points of inflection there, one at negative 1 plus the square root of 2 and negative 1 minus the square root of 2. As far as the denominator goes, we know that this will never equal 0. Okay, I did the work over here. Remember, it'll give me imaginary numbers. So this is the only critical points I need to check. So I'm going to have to plug these x values into here, which gets quite interesting, doesn't it? So let me pause here, clean this up, and we'll have to save this and come back to it. Okay, so what you're looking at right now is x equals negative 1 plus or minus the square root of 2. We're going to take this in 2 parts. So let's start with, come on, get that out of your way. Let's start with x equals negative 1 minus the square root of 2. So y equals natural log. I'm going to plug in negative 1 minus the square root of 2. I'm going to square that. Plus, I got 2 times negative 1. And hopefully after I do the first one, that will help me with the second one. Alright, so what I'm going to do is FOIL this. Negative 1 times negative 1 is positive 1. Negative 1 times that would be positive square root of 2. And then I have positive square root of 2 again. And plus root 2 times root 2 square root of 4, which is just 2. Multiply the 2 in, that'll be minus 2. Minus 2 root 2. Oh, look at that. It's kind of nice. Plus 3. Alright, so y will equal natural log of 1 plus 2 root 2. These cancel out. Minus 2 root 2 plus 3. So y equals ln of 4. So my one coordinate, my one point of inflection, will be at negative 1 minus the square root of 2. I'll be at ln 4. There's my first point of inflection. Now let's go after our second. Hey guys, since I'm running out of time, let me show you what the final is here. So when you plug in negative 1 minus the square root of 2, this is what you get, ln 4. Okay, when you plug in negative 1 plus the square root of 2, you're going to get ln 4. So here are your inflection points. So you got 2 of those. and your extremer, remember, was this. You have a minimum at this. So if you have questions, please ask, fire away.